Hey, what's up guys? I hope you enjoyed the last video and that we're going to be making some progress with Vulkan. Hopefully some quick progress with Vulkan and you'll be able to get up to speed, and then we're going to start doing some really interesting things. So what we're going to do today is we're going to implement a shader class, which will allow us to have multiple shaders going so that we can have multiple objects and, do some more technically cool things. So as I mentioned last time, I'm going to continue to do this on my Mac. If you have a problem with that, you want me to switch, everything's the same. It's all CMake and C-Line. A benefit to doing it on the Mac is that Metal is actually a little bit more... Metal or Mac OS X is a little bit more strict on the stuff I was doing with the renderer itself. So some small mistakes that I wouldn't catch while I was doing it on Windows, I actually caught when I moved over to Mac because it was just a little bit more strict. So with that being said, I hope you enjoy. Leave a like, subscribe, and let's just jump into the video. Okay, so when we left off last time, all we changed from the last edition when we made our triangle, or when we added input, was that we made it Mac compatible. So what we're going to do today is we are going to make some shaders. So to begin with, we're going to do a couple of things that I like to do. So the first thing is I'm going to reorder some stuff in here just to make room for later. So in our platform here, I'm going to actually just create a new folder directory called core. I'm going to move our game.h file into core, and I'm going to do the same thing in my source folder, and I'm going to make this core as well. Because it's not really a platform thing, it's really like a core component of the engine. Now this is going to fail to compile because it can't find some stuff. So window.reset, blah, blah, blah. Delete called on. Okay, so we're going to clean up some warnings before we start. So entry point, can't find it because it's looking for here. Should be able to find it. We'll do that. No such file. External engine source platform game.cpp. Oh, right. We want to reload our CMake project after moving all that stuff around. And then we'll build and we will see what it tells us. So a couple things. Did it build first? It did build. So it built. First thing, delete called on renderer. That is an abstract class but non-virtual destructor. So if we look at our renderer, we need a virtual destructor is what it's saying. So we'll do virtual renderer, and we will just do that. We can probably just do equal default, and we'll leave it like that. There's a couple more that are exactly the same thing. So renderer null pointer. Window is the same thing, so we'll go to window and we will add it here as well. Virtual window equal default. And I think render window, I think that's it. So let's rebuild that. And we've gotten rid of those warnings. Okay, so the first thing we're going to do is we are going to kind of abstract out some of our file system stuff. So we're going to create a new header here, just a header. And we're going to just call it file system. I'm going to add that to the project. We are going to perhaps once. Now, C-Line likes to muddy this up sometimes, so I just like to go back in here every once in a while. Yeah, see, and make sure that these files aren't being added unnecessarily. So we'll go into our file system here, and we are going to create some stuff. So the first thing is we're going to need the file system standard library. And we are going to make namespace Oz, and we are going to create an alias for the path as just path like that. Just because I don't want to have to type this in all the time, and I like looking at this better than I like looking at this. We're going to create a new class called file system. We're going to put a private label here, even though we're not going to use it. And we're going to make a public layer, and this is going to have a bunch of static functions here. So we're going to say static inline path get root path. Yeah. Come on. And here we're going to say std file system current path. And we're just going to return that. We're going to make another one, static inline path get shader path, like this. And we are going to say return get root path shader. Now what this is using the C++ 14, I think, file system API, which is nice because it will use the right path separators. This will make sure that you're referencing the right folders. This turns it into an absolute path, and then you can add different subpaths underneath. So that's what we're going to do for now for our file system. The next thing we're going to do is we are going to start creating a shader class. So inside our rendering folder, we're going to create a new header, and we're going to call this shader.h. We are going to say pragma once. And here we're going to make it's going to be fairly simple. We're going to namespace Oz again. And we are going to create our shader class, which is going to need a couple of things. Yeah, so it's going to be called shader. Easy enough. And we're going to have a few interface methods. The first one is we're going to use a virtual void bind equals 0, like that. And we're going to say a virtual void load const good string vertex shader const good string fragment shader. And we'll make that equal 0 as well. And we'll include string. And just like what we just did with the window in the renderer, we're going to need to put a virtual destructor here, like this, and we'll just equal default. Just as a quick rundown of what this is going to do, so our shader class is going to need it's going to have two main functions. It's going to be able to load the shader itself, and you're going to be able to bind it within your renderer. So if we look at our Vulkan renderer, just to show you kind of where this is going. And we look at I think it's called render frame. You see that there is a v command bind pipeline, and this is basically binding the shader. And when we load our shader, most of the loading code is actually inside our create pipelines here, right? So it's not going to be too difficult to move stuff around. To begin with, what we are going to do is we're going to need a Vulkan shader. So let's create this here, new C++ class, Vulkan shader.cpp.h. I want this to default to snake case. Okay. Add those to Git, and we will namespace all of this. Namespace it, remove these, and pragma once. And here we are going to also namespace. So first thing we're going to do is we're going to create our interfaces. So we can probably, well, first what we're going to do is we're going to reload this project. Actually, we want to include YouTube Engine rendering shader. And we want to subclass this as public shader, like this. And with that done, we can generate our override functions like this. We will generate these ones. We're going to need all of them. We're going to do that. And this is actually not going to be default. We're going to want to have this separate, like this. Now we're going to have a constructor on this object as well, and we're going to start doing some friend classing. So Vulkan, unlike OpenGL, requires quite intimate knowledge of the actual rendering pipeline in general as you kind of create objects and do stuff. You can't just do things whenever you want and just tell the graphics driver, hey, just draw an object. You can't do that, right? So that being said, all of our Vulkan objects need to have access to a lot of the rendering, let's say, state or functionality, right? So one way you could do that, and probably most people's preferred way of doing it, would be to set up an elaborate system for calling into the renderer and all of that kind of stuff, and make it a lot cleaner interfaces. Or what I'm going to do, because otherwise, like, it would add a whole bunch of code bloat, and if you're looking at it from a software engineering perspective, there's a reason why some things exist. So what we're going to need is a reference to our Vulkan renderer here, right? We're going to need access to our Vulkan renderer, and we're going to call this renderer. And it's going to be actually going to be a pointer to the renderer, and it's going to initialize this null pointer. Now this, we will include our Vulkan renderer here, and we will provide this as part of our constructor. Vulkan Shader, Vulkan renderer, like this. We will generate this, we will put it at the top, and we will initialize the renderer like this, right? So before we go through and implement the actual shader code here, we're going to actually create our shaders themselves, and we're going to replace our code inside our renderer with the call code. So here we have just these functions here. We're going to add a new function called virtual, and here we're going to return shared pointers. And this is going to be a shader, and create shader equals 0, right? Now shader here, we're going to need to include that, include YouTube engine rendering shader. Do that, and we will also include memory for the shared pointer definition. Now we can go to our renderer.h, and we are going to create that function underneath render frame, void stood shared pointer shader create shader override. All right, and then here what we're going to do is we're going to make shared, and we're going to pass in this. And this is not going to be make shared shader, it's going to be make shared Vulkan Shader. And we are going to, we're going to move this function up to where it belongs. Shut down render frame. Right here. We're going to put that here, and then we're going to import the Vulkan Shader here. Include Vulkan Shader. So here we are creating our Vulkan Shader, and we are returning it to the caller, which is all good. That's all we need. So from here, what do we want to do? We want to replace any instances of, let's say for now, we have, I think we should still be able to run this. So we have our triangle. We want to draw this triangle with our shader instead of using what it was doing before. So what do we want to do? So here we're going to notice here, if we go to our Vulkan renderer, we're going to need a shader. So here we're going to add a new section, and we're going to call this section, and let's get rid of that, temporary runtime objects, or runtime game object. So anything below in this section is stuff that we're going to be looking to actually remove from the render itself into our game layer that we are defining out here, that we talked about before. So inside our temporary, we're going to have a shader. So we're going to say std shared pointer shader triangle shader, and we will just initialize it as null pointer. Right? Now for our triangle shader itself, we will go inside here. So here we're going to want to say, let's say triangle shader equal create shader. And then we will want to say triangle shader load. And we will want to load this shader. And we will want to load actually it's Vertex Shader, fragment shader. So it's going to be Vertex Shader, fragment shader like this. That will load the shader. And all of this stuff will be part of that. And then in our rendering frame, let's go back to render frame. Instead of VK bind pipeline like this, we are going to say if triangle shader, because we want to make sure it's not null, triangle shader bind, like that. So this one we would want to have commented out, and all of this stuff here we want commented out. Temporary pipeline building like this, and we can comment all of this out. So that's what we want. We want to have everything be this simple, right? So how do we start that? Now we can start actually implementing our shader with one last thing inside our shutdown function. And actually, if we look at our renderer here, we don't want these pipelines. Pipelines are shader objects, so we want to delete those, which might cause some errors inside our code here, but that was the point. So here, instead of destroying the pipelines, we're going to say if triangle shader. We are going to say triangle shader dot reset and triangle shader equal null pointer. I think reset, again, I think I mentioned this before, I think reset makes it null pointer, but just in case it doesn't, I'm just being extra explicit here. It's something I plan on looking up. Anyways, we can delete this. We'll actually comment this out because we'll need this code again. So one by one, let's go to our Vulkan Shader and look at what we need to do. So Vulkan Shader, we'll start with the loading code. So the loading code is literally going to be mostly the code that we commented out down here. So let's just copy paste all of this inside. So let's cut that out, go into our shader and paste that in, and then let's uncomment it and see where we need stuff. So Vulkan utilities, we don't have that. So let's one by one fix some of these. Include Vulkan utility like this. Device we'll deal with later. File path here. So what we're doing now, so if we look at this load shader module, it's only doing this C path here. We're going to actually change it for a minute here. We are going to take the shader module path, and we're actually going to have a specific shader directory that we're going to use throughout our engine. Now you can set this up however you want, but this is just how I like doing it, just because it means that all your shaders are going to be in the same spot and you're not going to play with path nonsense. So what we're going to do here is we're going to say file system get shader path, and we just made that shader name. And we're actually going to call this shader name too, because it's no longer a file path, it's a shader name. And we will want to include file stream here. So include YouTube engine platform file system and file system like that. And that will automatically do the shader path stuff for us. And let's go back to our shader. Now here, instead, we notice how we're only taking a name. So we're just going to say Vertex Shader. Vertex Shader. And this is the frag shader. So let's actually move this down just because I like doing things in order, and it won't be as confusing for myself. So we will do the vertex shader first, and we are going to rename triangle vert shader to just vert shader because it's no longer specifically a triangle. And we are going to say vertex shader here. And we're going to rename this one as well to frag shader. Vulkan initializers, we are going to need that, so let's include that as well. Vulkan initializers. Triangle pipeline layout. So we do need a pipeline layout in our shader, so we're going to make that a private thing here. So we're going to just say Vulkan handles, and we're going to vk pipeline layout. Let's just say pipeline layout, and this is going to be initialized as vk null handle, and we're also going to need the vk pipeline, which is going to be pipeline vk null handle. All right, so let's go back here. Our triangle pipeline layout will become our pipeline layout like this. Vulkan pipeline builder. Oh, apparently that's another thing. So we're going to include Vulkan pipeline builder. And what else do we have? Window extent we're going to deal with as well in a bit as well. And window extent. Again, this will be pipeline layout. And this is going to be pipeline. Device render pass. All right. So for the most part, we've got most of everything we need done here. We've basically just copy pasted the code that was originally in create pipelines in our renderer and moved it into the shader class. But you'll notice now that the things that we weren't able to do directly are all rendering all things that are directly tied to the state of the renderer. That's a good way of saying it. So how do we want to deal with this? What we want to do is what I was talking about before. So you notice how we passed in the render itself. So if we wanted the device, we would hopefully want to do like renderer.device like this, right? Or like this because it's a pointer. But you'll notice here it complains that it's all a private member. So let's just do that everywhere and we'll fix it in a second. So that's a private member and that's fine. We will deal with that. So again, we will get the window extend. We'll do this. Now, some people will tell you that this is really, really bad. I disagree. I think there are use cases where you want to use this, but what we are going to do is we are going to declare our shader a friend class of the renderer, which makes perfect sense to me because if you think about it, the Vulkan shader, not the shader in general, just the Vulkan shader only exists in context of the renderer. So it makes sense for that to be a friend. So let's make friend class Vulkan Shader like this. And what that will tell it is that the Vulkan Shader itself has access to all of the private and protected members of the Vulkan renderer. With that said, we've pretty much got everything we want to do. So now that the pipeline is... No, I gotta go. It is officially time to eat dinner, so I will be back. Okay, so where were we? We had just finished loading the shader. So let's remove any words so we don't need to keep this, and we don't need to have the word triangle anywhere. It's always good to clean up when you're copy pasting stuff around. Okay. Temporary pipeline building. It's no longer temporary. Creating the viewport scissor. All right, I think that's good. Now, this bind function. Let's go back to our renderer. This is clean. Bind function was just one command. It was literally just this. So we can just put that inside here. Triangle pipeline becomes pipeline. and our command. And this is maybe a little bit dirty. At some point, we might want to have this acquire a command buffer or pass in a command buffer for these, because this is not, it's not the most efficient way to be rendering stuff, but it's not particularly inefficient. So we're going to do this for now. First, it's going to be renderer, and I think it's main command buffer. That's what we're looking for. And that will just draw the triangle onto, it's going to bind the shader onto the main command buffer. And there we go. Finally, last thing we need to do is our cleanup stuff, and I believe we left that in there as well. Did we delete this? No, let's remove this. Here. And our destroy functions we can put into here. And let's remove that. Again, these are render device, render device, and this will be pipeline, and this will be pipeline layout. There we go. Now, if I am good at what I do, this is going to work without issue first try. If it's like normal, we're going to have some bug fixes to do. That didn't work. Pipeline shader create info. Invalid shader module must be a valid module. Oh, that makes sense. So we the shaders directory is automatically passed in to our load shader module. So now, there we go. Now it's loading the triangle correctly using an individual shader. Now it's going to be a little bit more, it's going to be a little bit difficult to, we can show that we can have two different shaders by doing it like this. And we're going to make a triangle shader 2. And we are going to copy this triangle shader 2. And we'll say triangle 2.vert. Yeah, we'll do that. And then inside our Vulkan renderer.h, we will create another shader. And we will create one more shader for here. So, oops. So we'll say triangle 2.vert. And now you'll see here that we have positions and colors. Let's just say we want to render, let's just say a black triangle. And we want to do it in a different way. So we want to make it smaller. So say 0.5 f, 0.5 f. And then this will be minus 0.5 f, 0.5 f, and the tip will be at minus 0.5 f. So this will give us a smaller black triangle, let's say mostly black triangle that has a RG touch of blue in it. It fades to blue in it, and we load triangle 2. And I think we're loading it, but this should make it so that you can see that we're loading two different, failed to load vertex. So it didn't work because we need to reload the CMake project, which will add it to the file, which will make it reparse these names, which will make it so that it will generate the correct thing. So let's put it back in debug and we'll reload again. Now you should see here when we build it now, we get it inside. If we hit play now, we get the smaller triangle with a blue vertex at the top and black everywhere else, and it does a gradient. And that's multiple shaders working at the same time. So this is how you implement multiple shaders inside your Vulkan engine. There's going to be a lot more stuff going into our shader class and a lot of more logic going into a few things, but that's how we get the basic abstraction created. Next lesson, we're going to look into index buffers and vertex buffers so that we can start putting interesting shapes into our game. Then we will look at probably resizing the window and some other cleanup tasks like double buffering. Then we'll look at uniform buffers so that we can start loading data to our application, to our shader, so that we can start doing different things. But we'll get on that as we move forward. So as always, hope you enjoyed this. Like, subscribe, all that stuff, and I'll see you next time.